Hello, this is Xfixium and welcome back to how to make a Sega Master System game using Devkit SMS tutorial number 8. In this tutorial, we code the audio source file. I go over how to convert VGM formatted audio files to PSG files using a tool on smspower.org. Then finally, we compile our game for the very first time and run it playing audio. Exciting stuff. So let's dig in. We got all our globals and our defines in place. We're going to move on to the audio source as our first real source code. And what this will do is we're going to define some functions here that will play audio that we have set up as external resources, the same way that we have these as external resources that go in the bank. Our audio data or audio files will also go into these banks as well. And I'll show you how you would take certain formats, audio formats, and convert them over to something that the Sega Master System can use. And what we're going to output is a PSG file. And we'll use that in a bit here. First function that we're going to bring over is the play track function. It doesn't return anything, void, if you recall from one of the prior videos, means that it doesn't bring anything back. This is the actual name of our function, which is play track. We're going to hand it a track, which is one of our defines that we put together previously. So it would be one of these audio tracks, so one of these constants. So that's what we're going to hand it into it. So these are parameters or arguments that we're going to pass into this function that we're going to use for the logic that's within the function, which is within these two curly brackets, or a block of code. Here we're going to check if the track is the audio extra life sound. The extra life sound will hold priority to anything else that's currently playing. We can play one background track at a time, so when the extra life sound is playing, we don't want to overwrite it or interrupt it. So that's what it's saying here. So if anything else coming in, if the current track is already this, then we don't want to overwrite it. We're going to wait until it gets done playing, and then anything after that will be able to be set here for our track. This is a local variable where we're going to hold the PSG track that we want to play. Here we're going to set the previous track to the current track. So again, so we have some sort of memory of what was played previously, and that'll come into play. So after like the extra life tone is played, we need to know what the previous track that was played so we can go back to it was. So here we're going to remember what that is or keep track of that. So I'm going to take the current track, I'm going to set as previous track, and then this new track that we're handing it, we're going to set as the current track. So here I have a switch statement. Switch statement is a bunch of conditionals that we're looking for in one set. So what we're going to do is switch, and we're going to look at this track coming in. So based on what this track is or what we anticipate it to be, we'll do something for it. So what this is going to do, we're going to look at track, and we're going to say, okay, is the track the audio BMG? Is it the audio ready? Is it the player chomp sound? Is it the energizer sound? Is it any one of these defines that we already came up with. Is it any of these audio tracks? And then if it is, after this colon, it's going to execute the code where it is true. So it's looking at this variable coming in, or this parameter coming in, an argument, however you want to look at it, and it's going to do something based off what we handed it. So it's going to look at any of these valid values that may be an audio check that we hand it, and then what it's going to do is it's going to set our audio bank from when we talked about it in globals. It will set that audio bank to that audio track, and then it's not created here. That's why these are all on the red. I have to create these, so they haven't been put through assets to banks yet. So that's why they're all squiggly at this point. So it's going to set the bank for that one after assets to banks creates those for us, those constants. And then we're going to set the track that we want to play based off of this constant. So that's what we're going to do here. And then once we set that up, we're going to stop any current existing audio. And then based off of if we want it to repeat or not, so it's going to be a 0 or 1 that comes in here. We're going to either play it as repeatable, or we're going to use PSGlib's call to not call it as a repeating audio. So and these two are from these two functions, and this one here are all from PSGlib, and that's what we're using here to play the music, stop the music. Again, it's our library that we're gonna use going forward. Next function is our play SFX function. We'll just play a sound effects that we hand it. Again, that's very similar to this. We're going to hand it some parameters or arguments here. In this case, we're going to send it the sound effect that we wish to play, which again, we have those defined back in our defines source code. So it could play any one of these, and then it will check to see which one we want to play. So based on which one we want to play, we're gonna, if this is true, let's say if it just wants to play the confirmed sound, the bank for the sound effects will be set. Again, we're gonna create those in the future. And then the actual PSG audio data is going to be set here. So and we're going to prioritize all other sound effects over the pellet sound. So all other sound effects should interrupt the pellet sound. So here we're using PSGlib's status check. So it's going to check, all right, is any sound being played at this point? Sound effects being played. So if one's being played and the sound effects does not, or the current one, the current sound effects does not equal the pellet, and the new one is the pellet sound, we don't want to cut off any other sound with this conditional, so we return. If that's not true, then we're going to play the sound or the sound effects. We're going to set the current one to what we desire to play, and then we're actually going to play it given the channel here. So as I said in a previous video, the master system has 4 audio channels. 3 of them are a tone channels, and the last one, the 4th one, is a noise channel. So you can set however you create your audio SFX to use certain channels based off of this, and typically it'll either be the noise channel, which would be the 4th one, or it might be a combination of the 4th channel, which is the noise channel, and the 3rd one, which is a tone. And our And the tool that we'll be using coming up, I'll show you where you can define that and then use them within your game code here. Then the last function that we need for audio is display audio, and you might have recalled that's where we have it defined here in main, and we call this right after our v blank occurs. So right after it gets called, or once we hit that v blank, then we can play that audio. And then what this does is it calls a PSG lib function called PSG SFX frame. So this is for the sound effects, and then this is for the background audio or the regular audio. And this needs to be called every frame, so that's why it's named this way. And it'll be called every time the v blank occurs. So, and as you can see, what we did here, first of all, it doesn't return any values, it doesn't take any values. And what it does is it takes whatever the currently banked sound effect is, and it plays it here. And then it takes the currently banked or loaded background music audio and then plays it here. And then this is for that extra life, so when it gets done playing, so if the current track is the extra life track, and then we check that it's done playing, and the substate is under 6, which I think that has to do with the stage. If it's at a point where the stage isn't done, so we're not going to play the sound when the stage is done, or when the player dies, or some other substate that I'm gonna show you later. You don't want it playing at a certain time during our game run, so that's what that check is. So if it's if this conditional is true, then we're gonna set the previous track to the current one now, and then we're gonna play that remembered track, and we're gonna set it as repeat. That's why we have it set to 1. And that's really all this is. That's those 3 functions are it. So what we're gonna do is I'm gonna go over what the file formats that we're gonna use here, and then how to convert them using a tool. Take a look at that. We're gonna download that and we're gonna use it. I'm gonna show you how all that's done. First off, disclaimer, I am not an audio expert when it comes to the Sega Master System. I don't really create music, or I don't really have the ability or know how to create music for the Sega Master System. I rely on the kind donations of others and their talent. So, as you may have seen some of my other projects, you have various other talented people that have created tracks for the games I'm currently working on. And for this particular game, Slogra and Enrico Palazzo from SMSpower.org helped put these audio tracks together for me so that I can use them within the game. So many thanks to those two. But if you want to create audio for your game, generally speaking, there are 2 major applications out there that you can use. One of them is Furnace. And if you, when you create your composition in Furnace, what you would do then is export it as a VGM. And then I think it gives you some options to, right there's the Master Systems chip. So what I'm guessing is that you can use these 4 channels that we talked about before at the end here as part of your composition. Then you export to VGM, and then we're gonna use a tool to take that VGM and create a PSG out of it. So this is one. Defo Mask is another one that will do the same thing. So you will create your composition, and then you can save it as a VGM, and then from there we're going to use a tool, the same tool I just talked about, to create a PSG out of it. So, and that tool can be found under, well, let me go back. So you would search here PSG lib, that's what we're going to look for, and then this is the link that you want to use to get to it, the GitHub link. So again, this is a repo that's kept up by the same individual who created Devkit SMS, so big hats off to Sverks, I hope I said that right, who created all this. And honestly, I wouldn't even probably be making a Sega Master System game if it wasn't for all the hard work that they have done, along with Emulicious. Just those two things are very valuable when you want to create a more higher level game out of it. I mean, eventually I probably would learn assembly, but I can't tell you if I would actually be even making a game if it wasn't through this. So so PSG has a bunch of information out here, but this is the tool that we'll be using to actually convert our VGMs over. So, and I'm going to go to my file folder here, and what I did in our project folder that we have, so this is our project folder, went into that resources folder, I created a new folder or directory called audio, and then I put all the generous things that were given to me that are, as you can see, are in VGM into this folder, and then I put that tool in here, the PSGTool jar in here as well with everything. Okay, so we're going to click on that link, and it's going to take us to smspower.org. This is the creator of Emulicious, and this is a post where they show you the tool so you can download it from here. And then these are it's a command-driven application, so these are some of the arguments that you can put in there, and we'll go over some of that. And this would be the actual command line argument and the options that you have for it. So it would put up the same way that we run Emulicious. We put Java as our starting point, and then we're going to execute a jar file, which is our PSGTool jar. And then the input file, which is the VGM file that we want to convert to PSG. So we're going to put that file name in here, and then we're going to put what our output file name should be for the PSG. And then these other options here, 2, 3, and 23, are our channel options. So we can use 2, 3, or we can use the combination of 2 and 3 for our channeling. I know I said 4 of them, but we're starting from 0, if you recall. So that's what these options would pertain to. And then some other options here. You can split it up. You can make it that you don't want to compress by default as the compressed file format. And then the frame rate, which will come in handy. We won't be using it here, but when there's a PAL version, you may want to take your original track and make it for that 50 frame rate or something of that nature. I think by default, just again, it says it just takes whatever the input frame rate is from the VGM, but you can set it for NTSC or PAL if you like. Now that that's out of the way, we're going to right click, and then we're going to open up the terminal from where the PSGTool.jar is and where our VGMs are located. So we're going to do what it originally said on the forums. So we're going to look at this. So it's going to copy a bit of this. Then we're going to go back into our terminal here, and we're going to put in that information. Then we're going to change or convert one of these. We're going to convert the audio ready VGM. So I'm going to put that as an argument, audio ready dot VGM, and then we're going to hit space. I'm going to put audio ready dot PSG and enter. And then if we go back to our audio, you can see audio ready PSG is ready to be used. And what we're going to do is we're going to copy this, and then we're going to place that into our assets folder, and we're going to paste it in. So we have audio ready, and we're going to go back to our source code. We're going to run assets builds bat. So here, again, it's telling us the banks that we have, 2, 3, and 4. And as you can see, audio ready PSG bank, audio ready PSG is now not erroring out. So we now have availability to that because I built it through the batch file. And for a test, I'm going to comment everything else out except for the one that we have currently. So the only thing that can run is audio ready. So, and then here I'm going to comment out some of this other logic because we don't need it and our compiler won't like it if we try to do that. So as a test, first we're going to see if we can compile this with compile bat, see if there's any errors. Since we've done all this source code work, but we haven't really tested if it actually builds correctly without an error. So it built. You can see here that where the make SMS converters being ran, and here's the total amount of bytes used in the entire game, saying that we have using 50% of 80K at this point. And then, as I said prior, we have that bank 0 and bank 1. Bank 0 and bank 1 hold our source code unless we're doing bank switching for code. We're not in this instance, like I said, because we're going to be below the 32K that combined of bank 0 and bank 1 have for us. So we're going to be below that 32K, so we don't need to do any sort of bank switching when it comes to code. But this is giving us some information here. So it's saying that our first bank, which code would live in typically, now has 13,610 bytes left or available to still use for our code. And then bank 1, which is 16,326, hasn't been touched yet. So it will use everything in this bank first, and then if the code is more than that, it will start using out of bank 1 until there's more left. If our code goes beyond these two banks combined, which would be 32K, it will not compile correctly. It won't work because we went over our limit for how much code we can put together, which is 32K in this case. So that's why there's the idea of code banking. So not only can you bank our resources or our binary data, but we can also bank actual code. So, and then what would happen there is you would keep your static code or the code that you would need the most in the first bank, and then in this bank 0, and then bank 1, what would happen is you would swap out the code that you would need as you would need it, basically as you're going through the application, so, or the game. So it would bring in the code that you need to run, whatever function it is, and then you can swap it out for another set of functions, and that's so on and so forth, so you can bank your actual code, your source code, which would be C files. So it would be a source file like this, but it would be C, and you would also have some other syntax there that would denote that it's a bank, and then in your batch file that would setup would be a little different too. But we're not doing code banking at this point. We're just using the 32 that has available, so we don't have to do anything special here if we're planning on being below that 32K threshold. So okay, so we have that. It built for us. It showed us our code banks. It also showed us our other banks that have our resources in it. And then what we're going to do is we're going to go to main, and what we're going to do is we're going to set up our track. So we're going to play a track in the beginning here. So in the beginning, we're just going to call play track, and then we're going to say which one that is. So remember, defines, we're going to play that ready, and then we're going to repeat it, I guess. So I'm going to set that up. So this is where we're setting up the audio ready play track, and then it should play it in this play audio in a loop. So I'm going to save that. Everything is saved, and then we're going to call the next one, which is compile run, which again is over here, this batch file that we created. We're going to actually call it. This is how we call it. You know, with the dot and the backslash and then the actual name of everything, and hold on to your butts. And there we go. I played a track. And I think that's everything here. What I'm going to do here is that I'm going to, behind the scenes, I'm going to convert all my VGMs over to the PSG format, and then I'm going to bring them into the project. And then next time we're going to go into another part of the game, which most likely we're going to go to the common source code. And I hope you enjoyed this, and I'll see you next time.